Hey, this is Horner, and this is AP Physics C, 1995, and this is problem M1, so mechanics problem 1. We have a 5 kilogram ball on the edge of a table, and then we have a half kilogram block, and this is a frictionless table. The block is moving at 26 meters per second. It collides with the ball. And when it does that, it causes the ball to leave the table in the direction in which the cube is moving. And there's a figure below that shows a graph of kind of what's happening. So you'll see this is force and this is time. So they want us to go through, and the very first thing they want us to do is figure out what is the total impulse given to the ball. So the first thing that you need to do is give an equation. So you can either say well, you know what, let's get rid of those dots there for just a second. There we go. So we know that I is equal to, and you can do it one of two ways. You can do the integral of f dt, or you can write I impulse, or j, either one, doesn't matter, is equal to f delta t. So that would give you a point. And then you have to kind of show that you need the area under the curve. So that's what the integral does. That's also what just finding f delta t will do too. So we're going to say I is equal to, and then we have two triangles here, and so we're going to take 2 times 1/2 of, and then we've got a force here of 2 times 10 to the 3rd newtons. And we're going to apply that to 4 times 10 to the -3rd seconds. So be really careful. Here's your 4, but it's not 4 seconds. It's 4 times 10 to the -3rd seconds. You have another 4 seconds over on this side, hence why we've done 2 of the triangles. So we've actually looked at this triangle and this triangle. And then the last thing we need to do is we have to add to this rectangle in the middle. And that one is 2 times 10 to the 3rd newtons. So watch out, there's the force. And we're going to multiply that times 2 times 10 to the -3rd seconds. So once you do all your math, you should end up with your answer. So your impulse here is equal to 12 newtons times a second. So really easy thing to do. Really shouldn't take you much time to do that, or much effort, either one. Let's go ahead and take a look at item B. So for item B, they want to know what is the horizontal velocity of the ball immediately after the collision. So to do this, we need a correct expression relating impulse and momentum. So we can say impulse J, so we'll switch to J here, is equal to the integral of mdv. So that's mass times the change in velocity, and that's going from a initial velocity to a final velocity. Or you can just write J is equal to delta P, or you could write J is equal to M delta V. So remember, when you do integrals, you have to use dV. If you try to put dV here, it wouldn't make sense, and if you put a triangle here, it won't make sense. So be very, very careful with that. At this point, we can say now we've got the mass of the ball times the velocity of the ball final minus the velocity of the ball initial. Since the ball is at rest initially, we don't have to worry about this guy right here. And then we're going to substitute and solve for the final velocity of the ball. So the final velocity of the ball should be equal to the impulse on the ball divided by the mass of that ball. So this is equal to, remember we said the impulse is 12 Newton seconds, and then we're going to divide that by 5 kilograms, and you should end up with a velocity of the ball final of 2.4 meters per second. Next thing that they'd like for us to do is determine the following for the cube immediately after the collision. So now we've gone from the ball to the cube, and so because the cube hits it, we know that we've we've got to have, the cube has got to have an equal and opposite value for that of the ball, or you just have to show conservation of momentum. So the way I would do this is use conservation of momentum. So you can say mass of that cube times the velocity of the cube, and that's before, plus the mass of the ball times the velocity of the ball before should be equal to the mass of the cube times the velocity of the cube final, plus the mass of the ball times the velocity of the ball final. Since we already know the velocity of the ball final, we can go through now and we can find the velocity of that cube. So the velocity of the cube, so the final velocity of the cube, should be equal to the mass of the cube times the velocity of the cube, original, minus, and then we have the mass of the ball times the velocity of the ball, and that's the final velocity, and then we're going to divide that by the mass of the cube. So we'll go ahead and put everything in. We know that here we've got 0.5 times 26 meters per second minus 5 times 2.4, 2.4 meters per second. And then we're going to take all that and divide by the mass of the cube, which is 0.5 kilograms. And your correct answer here should be equal to 2 meters per second. Next thing you want us to do is figure out what is the direction of travel, right or left, if it is moving. So because the speed here has a positive value, the cube is moving to the right. And that's all you need for it, and that will give you your 1 point. And then the next thing that they want us to do is figure out the kinetic energy dissipated in the collision. So because it's not perfectly elastic, you're going to have some kinetic energy that kind of comes off here. So we know that our kinetic energy here, change in kinetic energy, should be equal to the kinetic energy of the cube. That's the final kinetic energy plus the kinetic energy of the ball, final, minus the original kinetic energy of the cube. So we'll put an I on that one. You know the expression for kinetic energy is equal to 1/2 mv squared. And so here we're going to say the change in the kinetic energy should be equal to 1/2. And then we've got the mass of the cube, the final velocity of the cube squared, plus the mass of the ball times the final velocity of the ball squared minus the mass of the cube times the velocity of the cube initial squared. And now we can plug everything in. So this is 1/2 of 0.5 kilograms times 26 meters per second squared plus 5 kilograms times, I'm sorry, this is 0.5, yep, this one is 5 kilograms times 2.4 meters per second squared. And then we're going to subtract from that 0.5 times 2 meters per second squared. And all that will go in that parentheses. So your change in kinetic energy here is 154 joules. Next thing they want us to do is determine the distance then that between the 2 points of impact of the objects on the floor. So this is a real stretch. Here we go. We know that our kinematic equation is the change in position, so the change in the y should be equal to the speed in the y original times t plus 1/2 of gravity times time squared. We know that the original velocity here is 0, so our time is just going to be equal to the square root of 2y all over g. And now we can plug our numbers in, so that's the square root of 2 times 1.2, and then gravity on the bottom, which is 10, And so we end up with a time equal to 0.5 seconds. So now that we know 0.5 seconds, let's go ahead and we can say that the position in the x direction is equal to the velocity in the x times time. Because remember, when they fall, they're going to fall like this. So you're going to have one fall in one place and one fall in another place. This is your table. So there's your table. We're going to have two distances. There's one distance, and then you'll have another distance from the origin. So there's our two distances. One of these is going to be xb, and the other one's going to be xc. So one for the ball and one for the cube. The ball should fall here. The cube should fall here, a little bit shorter. And we're going to use the equation to figure that out. So the position of the ball is equal to 2.4 meters per second. I think up here we just have to be careful. Nope, that looks good. So 2.4 meters per second times the time to fall. And remember, the time to fall is the same as the time to go left and right. So both times are going to be the same. This one's going to be equal to 1.2 meters. So that's where the ball is. And then for the cube, this is 2 meters per second times 0.5 seconds. So that's just 1 meter. So the distance between the two is the delta x. That's equal to the position for B minus the position for C. And so you should get 0.2 meters between the two, because 1.2 minus 1 is 0.2. And that should be the end of this problem, and it is.